Assalamu alaikum dear students. In the previous lecture we studied about the chemical properties of an acid. We studied about what happens when acids react with metals, what happens when acid react with metal oxides, what happened when acid react with bases, what happened when acid react with carbonates or bicarbonates, and thus likewise we studied what happens when acids react with sulfides or bisulfides. Now there are two more chemical properties that we will study, and inshallah we will be completing the acids along with bases. My property begins over here. Action with basic hydroxides. That is what happens when acids react with basic hydroxides. This is very easy. What happens when acids react with basic hydroxides? Actually, acids undergo neutralization reaction when they react with basic hydroxides. I repeat, acids undergo neutralization reaction when they react with basic hydroxides. That is, when acids react with basic hydroxides, they form salt along with water. I am repeating. What happens when acids react with basic hydroxides, they form salt along with water. That is, acids have undergone the neutralization reaction when they react with basic hydroxides. I am giving you the example so that it will be clear for you. Here I am writing acids when they react with basic hydroxides, they form salt along with water. We know acids when they react with base, they form salt and water. This reaction is neutralization reaction. So I am saying acids undergo neutralization reaction when they react with basic hydroxide, as they form salt along with water. I am giving you the examples. This is my potassium hydroxide. I am reacting with acid H2SO4. What I am getting is K2SO4 salt along with water. Fine. This is my basic hydroxide, potassium hydroxide, my acid H2SO4, formation of salt, potassium sulfate, and release of water. I can write over here carbonic acid H2CO3. This is my carbonic acid. This is my basic hydroxide. This is my acid. There will be formation of salt along with water. That is K2CO3, potassium carbonate along with water. So what we understood by this? When acids react with basic hydroxides, they form salt with water. Actually, acids undergo neutralization reaction when they react with basic hydroxide, and there is formation of salt along with water. We can write one more example as this is my sodium hydroxide. Sodium hydroxide. When it reacts with H3PO4, this is my phosphoric acid. This is my carbonic acid. When basic hydroxides react with acid, they form salt along with water. So what I am getting is Na3PO4 plus 3 times H2O. Clear? This is my trisodium phosphate. Trisodium phosphate. This is my potassium carbonate. This is my potassium sulfate. So what happened when acids react with basic hydroxides, they form salt along with water. This is actually a neutralization reaction. Potassium hydroxide, acid, sulfuric acid, potassium sulfate along with water. This is my property number 6. That is what happens when acids react with basic hydroxides. Now the last chemical property of acids, that is action with metal sulfides. What happens when acids react with metal sulfides? When acids react with metal sulfides, they form salt and liberate hydrogen sulfide gas. I am repeating, what happens when acids react with metal sulfides? When acids react with metal sulfides, they form salt and there is liberation of hydrogen sulfide gas. Here I am writing acids, when they react with metal sulfides, they form salt and there is liberation of gas, that is H2S, hydrogen sulfide gas. Now talking about acid, I am writing over here HCl, hydrochloric acid, metal sulfide, MgS. Fine. What I am getting is salt, MgCl2 plus H2S, balancing the reaction. Fine. This is HCl, hydrochloric acid. This is my metal sulfide, that is magnesium sulfide. I got magnesium chloride and there is liberation of gas, that is hydrogen sulfide gas, gaseous form. I can indicate this by showing the arrow. So when acids react with metal sulfides, they form salt and there is liberation of gas, that is hydrogen sulfide gas. We can take another example. Fine. What I am getting will be ZnCl2, zinc chloride plus H2S, hydrogen sulfide gas. So when acids react with metal sulfides, they form salt and there is liberation of hydrogen sulfide gas. This sums up our chemical properties of acids. And now we will be talking about bases, the definition of base, what are the classifications of base, and what happens when acids react with bases. Fine. Now, what are bases? According to Arrhenius, bases are the substances that release hydroxyl ions, OH negative ions, as the only negative ions when bases are dissolved in water. I am repeating. What are bases? According to Arrhenius, bases are the substances that release OH negative ions as the only negative ions when they are dissolved in aqueous solution. That is, a base is a substance that releases OH negative ions when dissolved in aqueous solution. Here I am saying again, I will be repeating, what is a base? A base is a substance that releases hydroxyl ions, OH negative ions, as the only negative ions when dissolved in aqueous solution. It is a substance that releases OH negative ions, that is hydroxyl ions, as the only negative ions when dissolved in aqueous solution, according to Arrhenius. A substance that releases OH negative ions as the only negative ions when dissolved in aqueous solution is called as a base, or we can write a base is a compound that releases OH negative ions as the only negative ions when it is dissolved in aqueous solution. Or we can say those substances that react with acids to form salt along with water are called as bases. That is another definition of base. Those substances that react with acids to form salt and water are called as bases. Fine. Now looking at the example of bases. We have so many examples of bases, like there is NaOH, sodium hydroxide. When it is dissolved in aqueous solution, it forms Na positive along with OH negative ions. Okay, another example is CaOH whole twice, that is calcium hydroxide taken in aqueous state. When dissolved in aqueous solution, it forms Ca2 positive plus 2OH negative. Another example is potassium hydroxide. One more example is magnesium hydroxide. One more important example, that is ammonium hydroxide. Ammonium hydroxide is a base. Yes, ammonium hydroxide is a base. When it is dissolved in aqueous solution, it forms ammonia NH4 positive along with OH negative ion. Fine. So these are the examples of bases. According to Arrhenius, I am repeating, a base is a substance that releases OH negative ions as the only negative ions is called as base, or the substances that react with acids to form salt along with water are also called as bases. Now looking at the example of bases, we have NaOH, sodium hydroxide. It is dissolved in aqueous solution. It forms sodium along with OH negative ion, that is hydroxyl ion. Now as we stated in the first lecture, there are three concepts regarding acids and bases, and I am only telling you about the Arrhenius concept. What about the Bronsted-Lowry and Lewis acid concept that we will be studying in higher classes? We say acids, according to Bronsted-Lowry concept, acids are the substances that act as proton donors, while as bases are the substances that act as proton acceptors. According to Lewis concept, acids are substances that act as tends to accept electrons, while as base is a substance that tends to lose its electrons. Now looking at this, because we have to only study about the Arrhenius concept, so according to Arrhenius, base are the substances that release OH negative ions as the only negative ions. So NaOH is a base, COOH2 is a base, KOH is a base, MgOH2 is a base, NH4OH is also a base. Now talking about alkalis. Alkali. Alkali or alkalis. Alkalis are the bases. Alkalis are the bases that are soluble in water and release OH negative as the only negative ions. I am repeating, alkalis. Alkalis are water soluble bases, those bases that dissolve in water or that are soluble in water. But alkalis are bases. All alkalis are bases, but all bases are not alkalis. That means all bases do not dissolve in water and do not release OH negative as the only ions. I am repeating, alkalis are the bases. Alkalis are the bases that are soluble in water. I am writing over here, alkalis are the bases that are soluble in water and release OH negative ions as the only negative ions. Yes, one more thing, all alkalis are bases, while as all bases are not alkalis. By saying this statement, we actually mean that all the bases do not dissolve in water and they do not form OH negative ions as the only negative ions. Fine. So all alkalis are actually the bases because they dissolve in water. They are soluble in water and they release OH negative ions as the only negative ions. Example, KOH, potassium hydroxide. When dissolved in aqueous solution, it forms K positive and OH negative. That is, OH negative ion is the only negative ion that is being produced by potassium hydroxide when it is dissolved in aqueous solution. Likewise, we have sodium hydroxide. When it is dissolved in water, it forms sodium positive ion and OH negative ion. So sodium hydroxide, when dissolved in aqueous solution, releases OH negative as the only negative ion. So it is a base as well as an alkali. I am repeating, all alkalis are bases. So alkalis are the bases that are soluble in water, that dissolve in water and release OH negative ions as the only negative ions. Potassium hydroxide dissolved in aqueous solution releases potassium ion and OH negative ion as the only negative ion. Now studying about the classification of bases, that is, how do we classify the bases. Classification of bases. Bases are classified on the basis of strength, on the basis of concentration, and on the basis of acidity. That is acidity of a base. I am repeating, classification of base. How are bases classified? It depends on what we are dealing with. Whether we are dealing with the strength, we are dealing with the concentration, or we are dealing with the acidity of a base. Fine. First classification of base goes on the basis of strength. That is, on the basis of strength. What is strength? We will be discussing this thing. Classification of base on the basis of strength. On the basis of strength, bases are of two types: strong bases and weak bases. Second classification, on the basis of concentration. On the basis of concentration, bases are of two types: dilute base, concentrated base. Third classification, on the basis of acidity of a base. On the basis of acidity, bases are of three types: monoacidic base, diacidic base, and triacidic base. So, bases are classified on the basis of strength, on the basis of concentration, on the basis of acidity of a base. On the basis of strength, bases are classified into strong base and weak base. On the basis of concentration, bases are classified into dilute base and concentrated base. On the basis of acidity, bases are classified into monoacidic, diacidic, and triacidic. We will discuss these as on one by one. We will discuss these one by one. Firstly, we will discuss about the strength of a base. That is, what do we mean by strength of a base? Strength of a base. Strength of a base means to what extent degree of ionization takes place, or we say to what extent degree of dissociation takes place. That is, whether a base completely ionizes in aqueous solution or it partially ionizes in aqueous solution. If a base ionizes completely in the aqueous solution and releases all the negative OH ions, it will be called as a strong base. While as if the base ionizes partially, it will be called as a weak base. I am repeating, what is strength? Strength of a base means to what extent degree of ionization or degree of dissociation takes place. It is represented by the same symbol alpha, and alpha is equal to number of replaceable OH negative ions upon total number of OH atoms present in a base. If the degree of ionization or degree of dissociation of a base, that is alpha, is equal to 1, the base will be called as a strong base. If its value is less than 0.7 or 0.6 or 0.5, it is called as a weak base. So, by saying the strength of a base, we actually mean to what extent the base ionizes in aqueous solution. If it ionizes completely, it will be called as strong base, and if it ionizes partially, it will be called as weak base. Degree of ionization or degree of dissociation is represented by the symbol alpha. Alpha shows us the numerical value. Example, how? NaOH. Find NaOH, sodium hydroxide, a base, caustic soda भी कहते हैं इसको. Na positive, OH negative. Find how many OH negative ions have been replaced. There was one OH and one is being replaced. So alpha is equal to 1. If the value of alpha is 1, it will be regarded as a strong base. So the value of alpha ranges from 0 to 1. If it is 1, it's a strong base, and if it is less than 0.7, it will be called as a weak base. Now, we will differentiate between strong base and a weak base. Strong base, it ionizes completely. Weak base, it ionizes partially. Strong base, the value of alpha, that is degree of dissociation or ionization, is 1. Degree of dissociation, that is alpha, is somewhat between 0 to 0.7. Third, in a strong base, when it ionizes, it only gives ions in the aqueous solution. It only produces ions in the aqueous solution, while as a weak base produces ions as well as molecules in the aqueous solution. I am repeating again. Strong base, it ionizes completely. Weak base, it ionizes partially. Strong base, degree of dissociation value is high and is numerically equal to 1. Degree of dissociation value is low and is numerically somewhat between 0 to 0.75. It produces ions in the aqueous solution. It produces ions as well as molecules in the aqueous solution. Examples of strong base: NaOH, KOH. Examples of weak base: calcium hydroxide or ammonium hydroxide, NH4. These are the examples of strong base and these are the examples of weak base. It comes in my exams, write 4 points about strong base or weak base, or differentiate between strong base and weak base. Now, talking about concentration. By saying the concentration of base, we actually mean the amount of base present in the fixed amount of water. Concentration, the amount of base present in the fixed amount of aqueous solution. That is, if I have 100 ml of aqueous solution, water, fine, and I am dissolving 50 ml of sodium hydroxide in it, 50 ml of NaOH in it. Concentration means the amount of base present in the fixed amount of aqueous solution. Fixed amount, I have 100 ml of water and I am dissolving 50 ml of NaOH. If the concentration of water is more than the base, concentration of water is 100 ml, concentration of base is 50 ml, water is more, the base will be called as dilute base. That is, concentration of water is more as compared to base. Likewise, if we say concentrated base, that is 100 ml of water and we are dissolving 150 ml of NaOH, that is, concentration of water is only 100 ml and concentration of base is 150 ml. 150 is more than 100. The base will be called as concentrated base. That is, concentration of base is more as compared to aqueous solution, water. Fine. So, on the basis of concentration, bases are classified into two types: dilute base, concentrated base. Dilute base, if the concentration of base is more than the that water, it will be called as concentrated base, and if the concentration of base is less than the concentration of water, it will be called as a dilute base. Inshallah, in the next lecture, we will be discussing more about the classification of bases